Hi, welcome to another 4AC learning video. In this video, we look at example 1.6b, which is found in your lecture notes. In this example, it reads, the 230 volt DC source delivers 100 watt power to a bulb. Determine the RMS value or the effective values and peak values of the applied voltage and current of the AC source. Compared to this one. If it is to deliver the same power to the lamp or to the bulb to produce the same brightness. Right, so we comparing something. DC supplied 100 watts. What's the AC I need to supply to produce the same effect? Alright, so how do we do this? Let's look at it. Yeah, looking at the DC circuits portion, the effective current is just the IDC, which is the power, which is 100 watts, divide by the EDC, which is the effective DC voltage, 230. Right, so this is watts, this is volt. That gives me a required current of 0.435 ampere. So in order for me to supply 100 watts to this lamp so that it will produce a certain level of brightness, I must make sure that there is a current flow of 0.435, whereas the effective voltage is 230 volt. Now in the case of AC, we have to apply the root 2 factor, right? So if we use the equivalent, that means the effective current required must be the same, which is 0.435. So the peak current that must be supplied for this circuit is 0.6152, which is derived from root 2 times 0.435. Now, what happened to the peak voltage required for this? Is actually root 2 the effective voltage, which is just 2 times 230 volt, which works out to be 32527 volt. Now what does this mean? It means that for an AC supply source to produce the same effect on this LED, we have to provide a waveform in such a way that the peak voltage must be 325.27 volt, which will then be able to produce a current level of 0.6152 in order to deliver the same power, which is 100 watts for the circuit. Okay, so effective voltage DC is 230 volt, so the peak voltage I must achieve has to be much higher. Okay, hope you learned something from this video example. Bye.